So yeah, I'm head of data science, and what I would like to maybe kind of talk you through is a little bit of my experience as well in our journey, and link that to basically how you actually develop AI. So of course there are like different ways, as we just heard, and I would kind of probably refer a lot to Richard. He made like really good points about many stuff. Some things you will hear basically again, but that just means that that's actually really the case. So I think that that's really good. Right, so maybe just first, quick introduction. So I am heading data science at Gousto. And basically what we do is we are in the kind of food market. It's a recipe kit service. So basically what we do, we make your kind of like preparing your dinner much easier. So that means that you don't need to really kind of think about that much what you will actually cook, and then try to take this hassle from you. So it's very easy. You choose recipes, then we will deliver you ingredients, and you will just really enjoy cooking then in the evening, or with your family, or with your partners and so on, even friends, of course. So what I think we are really good at, or what we are really focusing on, is kind of like value proposition, customer value proposition, and that's where, I mean, again, referring to Richard, it's really important when you also think about your strategy. It's really think about how that will actually help you, or how AI will help you to solve a lot of, or improve your customer proposition value. So in our case, that is on the market, we definitely have the most choice. So we have 40 recipes at the moment, and it's keep growing. Then we have most delivery options. So basically, we do deliver every day. You also have like AM and PM slots. We are working hard towards getting this even closer. So like the next day delivery, but it's really, really challenging if you imagine. Maybe like in comparison to ASOS, we operate with fresh ingredients with a quick turnaround. So it's quite a complex problem. And then yes, we do have best price, and I can say that that's definitely thanks to AI, through like different things like optimizing warehouse. So yeah, we'll be talking about that, but it's really, really important bit. So I always do this kind of little exercise. So how many of people really knew about Gousto before? All right, cool, quite a lot. So why I ask that, I always want to check this like against this chart. So when I started at Gousto, I always ask that, and in the beginning it was a bit like, not really many people knew about that. So, but I can definitely confirm that is following that positive trend, which I really like. So what that chart is actually showing, what I really want to talk about is how we were like, how we invested actually in AI fairly early on. So this is actually when I joined, basically it was end of 2014. I was the first person at Gousto. At that time we were like 30 people all together. I was one of the 6 tech guys, let's say, for example. So it was, as you can see, probably like comparing to the size of the company, that was fairly early on. And again, there was like our CEO at that time had a really good view on why actually we need AI or how data science can help. And I plotted basically all our algorithms, how we started like developing over time. And yeah, probably you will see that there is like a lot of stuff that Richard mentioned. So we built it in-house. I'll be talking a bit about that as well, why we decided that way. But there are also things that we use AI where we are not building, we are not investing into the kind of in-house capabilities for good reasons, of course. But I'll talk about this later. So as you can see, so that was kind of, and then in 2016, we were like 3 data scientists. Then in 2017, it was like 6 already and so on. So it's kind of growing quite fast, I would say, for comparing to our company size. So it is, from the business point of view, it's really, really important. So we can actually say that it's a lot of parts of the business are AI driven. Right. So I would like to talk about there are like different ways of kind of engaging with AI. But the main thing I would always say is like start simple and iterate fast. So as fast as you can. So you don't need to overdo stuff. Definitely think about how you can start simple. And that I think was the case, with us when I joined. It was very much let's build something simple. It will, that will help us with the customer value proposition. So for example, we started working on demand planning, and that actually helped us to reduce lead time, from 10 days to 3 days. So that means that, when I joined as a customer, if you as a customer placed an order, you got the box in 10 days. But then with that demand planning, we actually managed to reduce it to 3 days, which for a customer is that definitely really, really useful. Right, so, but before we actually talk about different ways, I just want to talk a bit more about like some myths that are there around, which are related to that, and then you actually engage with AI. So, you know, quite often people, I mean, you can hear that, oh yeah, AI is just a hype. Well, I do agree, it is a hype, but actually, you know, it's a positive thing, so people talk about it. Of course, as Richard said before, you know, it's not something that will kind of just solve all your problems, that you will just say, look, here is my data, solve it for me. It doesn't work that way. But there are definitely many applications that, you know, were not possible to solve before. So AI definitely helped us with that. So like, I don't know, a voice recognition, object detection, you can't really code that, you know, as a program, like in rules. It's very much data-driven. The other one is that, you know, quite often people think like, especially in startups or scale-ups, oh, this is like just for big companies, for giants like Google, Facebook. Yeah, they're really good in it, of course. They're really kind of, you know, pushing boundaries. But there is like many opportunities, even like from, you know, smaller companies to actually apply AI and make sure that works well for them. So, and I can say that Gousto is one of them, of course. And of course, there is like a huge entry cost to AI, is what usually people say. Well, that's not necessarily the case. As I said, you can start simple, you know, and then iterate. So of course, you can then also kind of work with other companies, or you can start like using some existing solutions and just give it a try, see how that works for you, and then iterate on that. So yeah, I would say all these myths are kind of busted. Right, so and there are like different ways of engaging with AI. So one thing is definitely to consider is like, you know, what is your problem, how generic it is. So, or what is your, you know, business proposition, and you try to think about, okay, how I can apply AI. And depending on that, of course, there are like different ways. So yes, you can use third-party APIs that exist. I don't know if you want to, let's say, for example, just detect some objects or on your images. You know, there are existing algorithms, existing services. You can just send your picture. They will give you back like, you know, objects on this picture. So in that case, why would you be building your own AI? Just use that. So it's definitely kind of like a best way to start with. Of course, you can then specialize if you need, but start simple is important. And then, of course, there is a question about like in-house versus kind of outsourcing. So yes, you always need to kind of consider about like, is that your like really, you know, value proposition? Are you helping the business? Because then, you know, it's yes, on one hand, you can start really simple. You just, you know, use managed services. But then on the other hand, if you start building it, you know, in-house, it will give you a lot of knowledge. You will learn about your business problem, business model, and long-term might be really to pay off because you will build like really competitive advantage, you know, against others, of course, other businesses. But then also you have like a hybrid approach. There, I think, where we are, of course, with kind of a bit over-indexing on in-house building solution. But there is also a good approach. So focus on things that you can really will deliver value for you, and then maybe use some managed services for things that, you know, maybe there is no, from more like generic systems, let's say, or problems. But I totally agree with what Richard said. So always kind of measure success. So that's really important because it will give you like a buy-in then for other projects. And in our case, that was, as you can see, then it's kind of like that positive trend in terms of how many people we have, but also how many projects we are working on at Gousto. It's really important because our first projects were really successful, and then we were just getting like more buy-in. Board is really supporting. LT, I mean, like leadership team is really supporting, and then it's much easier. You know, years ago we were in a position when we needed like to pitch, oh, we could use AI for that. Today it's the other way around. It's very much like, you know, different stakeholders coming to us. Oh, can we do that? Can we use AI for that? So it's actually a good place to be in. Right. And then just, you know, as we seen before, I will kind of skip really quickly through that. It's important to focus or understand, you know, what problems you have, what are really critical parts of your business that AI can really help you with it, and then start building a moat. So that will really give you like competitive advantage. So, and also definitely involve like, you know, your users or stakeholders, you know, really early in the process because they will give you feedback, and that's really important that you don't go like in a way that it's not useful. So definitely involve people, I mean, relevant people early on. Right, and just maybe, you know, quickly I would like to discuss about our mode. So we focused really on two things. It's similar to what Richard said before. So on one hand, you know, because our operations are fairly complex in terms of, you know, how, you know, we operate with fresh ingredients and so on, it's important for us that, we really build kind of like bespoke algorithms on that, and definitely helps. Well, then on the other side, it's similar. So we do personalized, we want to provide personalized experience to our customers. This is then through recommendations and so on. Why we decided to build our own algorithm, it's, of course, we started first with some existing frameworks. We realized that they don't really work well for us because in our case, the business problem is slightly different. We operate with food, which there are like also kind of, it's very subjective thing. There are some emotions involved as well. So we very much look on that from that point of view and try to solve this issue with our bespoke algorithms. Right, so, and then if you decide, let's say, that you need to go like a route where you want to build in-house capabilities, for example, you know, data is the first thing that you need if you want to build AI. Because really the data is kind of like the fuel of AI. So without data, you can't really do much. You can't train your model. So I would just like maybe like to quickly have a look. So how, you know, to collect data, where to store it and so on, to give you like an overview of that. And again, I borrowed, like similar to Richard, like a nice chart or diagram from that playbook. I don't know what page is, because I use the online version, by the way. It's online as well, free. Have a look there as well. But basically, there are like 6 kind of main components of it. So it's definitely like collecting data, so acquisition and processing, context, so you need to understand the data, then storage, where you're going to store it in a scalable way, then provisioning is important part. But all of these kind of parts are like, you know, you want to have, you know, you want to guarantee quality of your data. Otherwise, you know, very likely your models will be, you probably know about it, like rubbish in, rubbish out. So quality is important. And then, of course, everything around managing and security of your data. It's really important, as we heard before. You know, at the moment, we have GDPR compliance already, but it's very likely that there will be more and more kind of regulations around that. So, you know, it's important to think about that. So, but I want to focus just on 3 things that I think it's important to start with. So data collection, data storage, and data democratization. So with the data collection, I think just what I want like to land you as a message is, so quite often people think like, oh yeah, I need to start collecting data just internally. Well, that is probably like the most obvious one. Also think about, are there any other data sources that you can use? So think about like, you know, third parties. There are like some companies that collect data for you and can then it's like sell it. It might be cheaper, or at least if you need to build something quickly, you know, you get data immediately. Otherwise, you need to collect it for a long time. And then, of course, there are like free resources as well, like, you know, Google and Google data sets, search data set, I think. And then also Kaggle, for example, and so on. So always try to think a bit out of the box. So, you know, the most obvious solution one is not necessarily the best one to start with. But then, of course, like, you know, kind of collecting data, like internally, so to build like proprietary data set. There are different ways to go about that as well. So you have solutions like managed services where you actually can, you know, it's almost kind of like plug and play. So like Segment, but then on the other hand, you also have Snowplow, which we use really happily. It really works very well for us. There is Alex, speak to him about that. But yeah, really good. So it's always think about, you know, kind of ways of collecting data. Right, so, and then in terms of data storage, that is actually also a really important part because, you know, collecting data is one thing, but then, you know, storing it in a flexible way, scalable way is really important, that you can then have this flexibility. So I don't want to go too much into detail. So maybe one thing that is important, try to remember that, you know, maybe in the past, you know, everyone was building data warehouse. Today is more about data lake. So what it means, it will just give you more kind of like agility and scalability. So that means that actually you store raw data in your kind of like unlimited resources like in Google Cloud or Amazon. They all kind of offer you kind of storage that is really kind of basically unlimited. And then basically what you do, you then kind of build that data around. So you are transforming it and making it like available to others. But yeah, and then on top of that, definitely don't forget about compliance and security. It's a really important part, as we said before. So you don't want to be in a position when, you know, you lose kind of your customers' data. It happens to some companies, and it's really bad reputation. Besides, of course, some fee that you will get from, you know, now from GDPR or ICs. And then I think data democratization is really important part. I learned that because maybe we didn't start like, I mean, I still remember like the pain that I had when I joined Gousto. So at that time, we didn't have any data warehouse or anything. So a lot of the data was like siloed. And for data scientists, basically that is the worst thing that can happen because you're really kind of limited. You can't really do much if you don't have access to data. So I really got my hands dirty and get like the warehouse together so that we could actually start building really kind of AI capabilities. What it means, it's really important that you kind of give access to people. Don't try to put a lot of red tape on it and stuff, so always think about that. It's an important part of it. And as well, what is important, so when you're adding more kind of like data, when you're collecting it, it can easily become, on one hand, if it's easy to collect data, it can also easily become a mess. So when you have a huge amount of data and a lot of different data sources, it becomes more difficult for data scientists and data analysts to really understand what is what, and then people struggle. So it's really important to maintain that data catalog and that you know where things are and what it is about. Right, so, and then in terms of kind of developing AI products, what I really want to make sure is, this is kind of like big topic really to cover. There are like different ways of doing it with a lot of frameworks and so on. So for me, what I would like you maybe, I won't really go into too much detail because it would take us too much time. But there are like a few messages what you need to kind of understand. So what you should think about when you're deciding to develop your AI product, but also what kind of techniques or frameworks you can use. But before we go into that, I mean, we heard before that maybe developing AI is different to kind of like software engineering. It's quite different way of doing stuff. And I found this really nice representation what the difference is. So if you think about in software engineering, it's very much about you have input, you write a program, and that by using some rules or computation, it will give you a result. But with AI, it's really different. It's basically, yes, you get input, but then you have desired result. You actually say, okay, so this is what I actually want. So this is how it should look like, which means that then you don't write a program, but actually, by this, using computation or machine learning, you basically build a program that will then give you desired results. So that the next time when you get some input, you can actually, predict how the result will look like. And then you get the program out of it. So what it means in terms of complexity, so, so AI is really good for more complex problems. So imagine that you would like to, I don't know, like object detection, that you would want to kind of code that, with a lot of rules and stuff. It's basically impossible. You can't really do it. The same is with voice recognition. It's almost impossible to really kind of come up with a hard-coded algorithm. So it needs to be based on data. And then as well, so the output of that is like when you have a program or when you code it, it's very clear for this input, this is the output. While in AI, it's very much you will get approximation, you will get approximate result, and you need to take this into account, of course. And then development as well, I think, well, of course, software engineering is very iterative already, but I think that AI is even more iterative. So because you don't actually know, when you start building your model, you don't necessarily know what the output will be, whether you'll be happy or not. So it's really important that you have like fast iterations. So, try it as soon as you can, get feedback, and then iterate, make it better, make it better. Don't overdo stuff in the beginning because it will definitely slow you down. So in that case, it's very much more like focusing on, how to prepare the right data, how the good data describes my business model or process so that I can use it. And then as well, it's like what kind of algorithm I need to use, to build that program. So these are really kind of important things. It's kind of completely different kind of way of thinking. Right, and I just want to quickly cover like what AI techniques actually exist. Won't really go into details, but on a high level, so there are like different approaches. It's like you have supervised, unsupervised, and reinforcement kind of like learning. So what really the main differences are about that? So I think that picture kind of, our image presents it very well, but on a high level. So when you have unsupervised learning, it's very much about you have no idea what your outputs are. So let's say you have a group of people, you don't really know, what you would like to predict about them. You would just like to group them based on some characteristics, let's say. I don't know, whether it's their age or I don't know, well, gender, for example, you could do that. And then you would group them and you can use that for or personalization or maybe like different use cases. But it's very common kind of approach in business. And then supervised is basically where you know you have a training set, where you have labeled data, and then what you actually do. So you train an algorithm on that, that algorithm learns how to predict that, and then next time when you will get unlabeled input, so for example, if you want to predict someone's age, you don't know how old someone is, but based on some characteristics, or let's say, picture, you can actually predict that. And that's where that becomes really, really powerful as well. And then that actually then is kind of like split into more like kind of, when you have supervised learning, you can split that further into classification and regression problems. So just to give you an idea what the difference is. So in terms of when you do regression, you very much want to predict some continuous value. So let's say in the example of weather, it's very much you are predicting what the temperature will be tomorrow, for example. So it's like between, let's say, well, this is in Fahrenheit, but let's say in Celsius would be like between 0 and 30, 35 when it's really hot, like in this room now, at least for me. Well, then classification is when you just have basically binary outputs. So you say yes or no, or maybe you have a few more kind of values like, I don't know, colors, green, blue, red, and so on. So that's actually the main difference, how that approach really looks like. And then in terms of like these techniques, then you probably heard about deep learning as well. So it's a very popular approach nowadays. But my main message would be, I don't really want to go into details how it works. Let's say it's much more complex. Imagine that you have multiple layers and it goes much more into details. But the main message here is like you don't need to start with deep learning because Google talks about it or we see really good results. So it's important to think about, again, like how you can start simple and then you can iterate. Then yes, in the future, maybe at some point you will need to use deep learning. But in most cases, like for very simple problems, you don't really need to use that. And then on the other hand, what is also really important or became really popular approach is so-called like synthesization or generation. This is basically where you are not just kind of like predicting values anymore, but you're almost like generating new images or pictures or even like sound. So this is all kind of deep fake things that you probably heard about a lot. So this is actually how it works. Based on like multiple or millions of kind of good examples or samples, then they try to come up with something new, but still kind of valid. And that has like a huge, it's very powerful nowadays. Right, and then, when you think about all these techniques, so you don't really need to, don't think about, oh, I need to code the whole thing. There are many, many different kind of frameworks or tools that already have these techniques implemented. So, at the end, if when you approach that, so if you, to start simple again, you can use those. You don't really need to change the code of the algorithms. But then at the end, it can really kind of be as simple as kind of like, calling fit and predict. So fit is actually when you have your training set, you want to train a model, and then predict is just like getting inputs and predicting the output. So yes, that looks really simple. Then, in reality, it's not that much. You need to kind of like tweak your models, validate them, fine tune, and so on. But I think like as a good start is definitely where you can start. You can start playing with it. You learn how it works, and then iterate on that. I won't really go into what frameworks exist, but what I really want you to make sure to think about is that when you choose these kind of like frameworks, always think about like what kind of problem you're tackling. So the first thing is definitely you need to understand is that supervised, unsupervised learning, reinforcement learning. So that will then help you, to decide what kind of framework to use. And then, again, it's like, you always need to consider like complexity versus flexibility. So some frameworks are really simple to use, but not that flexible. You can't really change many things. While on the other hand, you have frameworks that are maybe a bit more like complex, but it will give you a lot of flexibility. You can change a lot of stuff and then kind of achieve better results. So it's definitely something to think about. And, of course, what is also really important is, how good community or support is for that. So imagine if you will start using some, framework maybe that is not that, popular, it might happen that you will struggle to find support or help, which is then much difficult when you're kind of stuck in your problem, you won't be able to find someone to help you out. So this is very much like kind of one-on-one examples, through kind of AI frameworks. So if you are bored with these slides, I have another one which is about productionization. But if you are not bored, then I would definitely suggest to have a look into this playbook and read about more, because there is like quite a big section about it and explaining a bit more into details. But so what I also want to cover, I mean, David, just to check, do we have time? Good, great. So productionization and AI products is something that I'm really passionate about, because a lot of people just talk about, yeah, you can build a model, you can play with it, and not so many people actually talk about how does that then run in production. What are the things that you need to kind of be careful about? Because the value of AI products are really when you have your algorithm in production. So if you just build your product, AI model, and then it's not actually giving you any value, it's not really that valuable. So just one slide and just a few messages to think about. So it's completely kind of a process or a separate process, in a set of skills that require to get your AI products in production. So it's very different to just kind of build a model. There is a lot of things that you need to think about, like from monitoring, validating, to make sure that when you deploy a model and you use it in production, that will actually give you the results that you wanted, so that it's not something that you just built in controlled environment, and then when you will go in production, it will be, it will give you completely nonsense. So you want to guarantee that that's not the case. And then, of course, it's really important to have efficient workflow. So as I said before, you want to iterate really fast. So if it will take you I don't know, a week to get this model in production, it will really slow you down. So in our example, so in the beginning when I joined Gousto, it was very much like that I build a model, then I ask software engineers to deploy it in production, and that was always really slow. So people were, we were all unhappy. So they were unhappy maybe with my code. I was not happy with their pace or how quickly they are getting in production, so it didn't work. So what really works best for us is to build that kind of ownership, really, ownership culture. So now, as in my team, we do have software engineers, we have machine learning engineers, and we have data scientists combined all together, and we own the whole workflow from the beginning to the end. So we build a model, we productionize it, we run it. So if something goes wrong in production, it's on us to fix it, no one else. So, and that actually really allows us to be fast. So whatever change we want to do, it's on us how quick we will be. So we don't have any dependency. And that's actually where we can really, really move fast. And then, of course, I mean, it's really important, I would say, to adapt engineering practices that works really well with AI as well, and also Agile. And a lot of people maybe say that Agile doesn't work in AI. I think it works really well, because it's really about iterative process. So you don't need to follow necessarily Scrum, but there are ways to be really agile in a way. And of course, we heard this before, so measure success. That means that, yes, I mean, accuracy, precision in stuff, these kind of metrics that are more technical matters, of course, when you're developing your model. But what really matters at the end is moving business KPIs. So I know with our recommendations, we've seen good results in the beginning, when we were just testing on our data set, but then when we pushed in production, it didn't really push any kind of KPI. And then, our CEO was like, I mean, good, you spent a quarter working on it, but there is no value. So then it was really important for us to spend another quarter to figure out ways, how we actually, push our KPIs. And now we are kind of getting much, much better menu conversion rate, for example, with recommendations and so on when we figure that out. So yeah, that's basically everything for me. So hopefully it would be useful. And if you have any questions, let me know. I'll be happy to answer.